So, to kind of follow up and just get some more notation about what we were talking about in the last example, we have our 10 jelly beans, 1 blue, 2 purple, 3 green, and then the 4 red. And we were talking about if we draw without replacement, what's the probability of choosing a green jelly bean and then a red jelly bean? So we talked about is that when we're looking for this, connecting the words with and, the idea that we have this sequence of events, green and then it's like taking the probability of green times this probability of red, but because we're working without replacement, so we don't have independence, we want to think about the probability of choosing red given that we've already chosen a green jelly bean out. So this notation, this is where we're getting our conditional probability. It's conditional because condition has already occurred. There's some condition to the second event. So the notation that we want to use is what's shown down. Ignore the actual formula for a second. But the notation goes, we have this bar in between the two events A and B. But what this says here is the probability of event A. And that bar we can read as given event B. So this notation here is saying what is the probability of event A occurring given that event B has already occurred. So if we take that to our notation up here, it's the probability of event red given that green has already occurred. So this line becomes a separator of the event that you're looking for the probability of, and then to the right of it is the event that's already occurred. So as we talked about with the calculation, it's like probability of green, this is our first event, so we're just using all of the jelly beans, and there's 3 green jelly beans out of all 10. And then for the second event, for this probability of red given green, it's the idea that we already took out a green jelly bean. So now calculating this, probability of red, so there's 4 red jelly beans, out of, and the fact that we've already chosen a green jelly bean leaves us with a sample size of 9. And that's where we get our value of 0.1333. So what we want to do in this section is get used to this notation, and we're going to look at it as an example where we have a table, and that's formula comes in for the calculation. But this brings through our multiplication rule that for non-independent events, the probability of one event and then the other, you take the probability of the first event times probability of the second event given the first already occurred, is how we calculate that. So, our formula here. If we're looking for this conditional probability, you take the probability of both events occurring out of the probability of the given event. So if we go back to that data with the 3 treatment groups and those lapsed and didn't relapse, say we're looking if a person took desipramine, what's the probability that they had a relapse? So with conditional probability, there's kind of 2 words that are going to come through. For example, it's the word if. It's the idea if this has already happened, if this is already true. Another word that's going to come through is given. Given this has already happened, given it's already true. Those are going to be keywords to look out for conditional probabilities. So if a person took desipramine. So following if and also following given, this is always going to be the past information. Just like how we had up here that we were given green. Green is the old info. Green's the first thing that occurred. So if a person took desipramine, this is our given event inside of the line there. This is our given information. Then they say, what is the probability they had a relapse? So whatever follows, like find the probability of, what's the probability of? What follows probability is the thing we want to look for, and that's always going to go to the left of the line. So just be careful with the placement of events here because it does matter. So what we want to do in order to calculate this is take the probability that they relapsed and were taking desipramine out of the probability of taking desipramine. So this right here is using our formula up above. Numerator is the probability of both events divided by probability of the given event. And while it's probabilities, they're going to have, like where we technically have a fraction divided by a fraction, when you have a table like this, you can just use the counts from the table. You don't really need to make the denominator. For example, probability of relapse and desipramine, technically the probability is 10 out of 70. Really, we just need that numerator. So it's that there's 10 people that relapsed and were on desipramine out of all of the people on desipramine, which were the 24. And that's going to a 0.4167. Now let's talk about this fraction in terms of the table, because sometimes it can make more sense to just look at the table than to make using the formula. The idea being, if a person took desipramine, so if we already know they're taking desipramine, that means we don't need any of this other information. We just want to focus on that row of the data. And so for this row where we just have these 24 people, what's the probability that they had a relapse? So 10 people relapsed out of those 24. So we have a conditional probability. It kind of limits the parts of the table that we're looking at. So with that, you can see how that fraction is formed without actually using the formula itself. So this would mean there is a 41.67% chance of relapse given they took desipramine. So that's our conditional probability. Let's try that with a few others down here as well. So given that a person had DM, what's the probability that they had a relapse? So making our probability notation. So we're going to have some event given another event. So we're going to have our line second event. So given that a person had lithium, so that's our given information, and we're looking for the probability of relapse. So that would go there. So this is saying the probability of relapsing given that they were taking lithium. So for calculating this, again, you can almost just do it from the table itself. We know they're taking lithium, so the probability of relapsing is that 18 out of 24, or you could think of that as the probability of relapsing and taking lithium, which would be those 18 people, out of just those taking lithium, which are 24. And that'll give us a 0.75. So there is a 75% of relapse given they had lithium. And if we just do one more, what's the probability that someone had a relapse if they were in the placebo group? So probability of relapse given they were taking the placebo. So you want to take the probability of both out of the probability of being in the placebo group. So 20 people were taking the placebo and relapsed out of 24 people in the placebo group. So there is an 83.33% chance of relapse given they were taking the placebo. So what's neat about this is we can see the effect of the different groups they're in. What's the chance of relapsing? You can see if they're in the placebo group, they're way more likely to relapse. And say if they were taking desipramine, that had the lowest chance of relapse there. So you get this idea of two variables occurring given some prior information. So with this, what we can see is how this given information, because all of these is looking for probability of relapse, probability of relapse, probability of relapse, however, given different information. And we get different probabilities out. And that's telling us something about our information. So if we're looking at this conditional probability, so if we're looking at this probability of event B given that event A has occurred, if that's just the same as probability of event B, then A and B are independent. What that's proving is that even if we're given the fact that A has already occurred, if it's just the probability of B, A didn't actually have any effect. They're independent of each other because the probability didn't change. So this means that knowing event A occurred does not affect the chance of B occurring, or kind of the probability of, if they are changed, then that's where we see not independent. So say we wanted to prove, is taking desipramine independent of relapsing? So what we'd want to do is look at these two probabilities. What was the probability of relapsing given they were taking desipramine? And was that the same as just the probability of relapsing? So if we calculate these two values, if they're the same, that's showing that taking desipramine didn't actually do anything. It's just the chance of relapsing, and the drug didn't actually matter. So on the previous page, we calculated this to be 0.4167. Our probability of relapse, that was our 48 out of 72, which is a 0.6667. So these are not the same. And this tells us a few things. If they're not the same, desipramine, taking that drug, changes the chance of relapsing. And if it's changing the probability of relapsing, the events are not independent. So this is what you want to do when trying to prove independence, is, are these values the same? If they're the same, they're independent. If they're different, they're not independent. You just set up one conditional and then one non-conditional and see how it comes through.